Hi, everybody. This is Professor Ross, and this video is about association and confounding. We're now going to be talking about when we have two variables, not just one variable of interest, and ways that those two variables might be connected. The basic idea of connections between variables is called association, and we'd like to dig in a little bit more to that. So let's go ahead and take a look at some notes here and talk about association and confounding. Our key learning objective today and also in our next video is going to be about understanding the difference between association and causation. And so we're going to find out that when we have two variables that are associated, it does not necessarily mean that one is causing the other to happen. Let's take a look at what we mean by association. Two variables are associated if the value of one variable gives you information about the value of the other variable. And here's a few examples. Let's say we had a categorical variable smoking and another categorical variable lung cancer. And an association would mean that knowing something about whether someone smokes would give us some information about whether they may have lung cancer. Now, we're not saying that we know if you smoke, then we know you must have lung cancer. But if we know you smoke, we may know something more about your chances of having lung cancer. And so, knowing something about variable one gives us some information about what might be happening with variable two, and that's called an association. That can happen between categorical variables. It can also happen when we have a quantitative variable like weight and another quantitative variable like height. If I know something about your weight, that won't tell me exactly what your height is, but I might have a better sense of your potential ranges of heights if I know your weight. Or vice versa, if I know what your height is, I might know something about your weight. That's called an association. And sometimes we can have associations between, for example, a categorical variable and a quantitative variable, like are you a commuter or a residential student at the college here, and what's your GPA? We may find an association there, knowing whether you're a commuter or a resident may give us some information about what we'd expect for your GPA. Note, association between two variables does not imply causation. So, and causation, we mean changing one causes changes in the other. For example, weight is associated with height, right? That seems reasonable, but that doesn't mean you should go gain a bunch of weight in order to get taller. It's not a causal relationship. Being a certain weight does not cause you to be a certain height, even though there is a connection there. Um, or, for example, commuter or resident, we might know there's a connection between that and GPA, but that doesn't mean that if you choose to, you were a commuter and you choose to become a resident, that that would cause a change in your GPA. Not necessarily. We may find that, but it's not always the truth that there's a causal relationship between two variables, even if they're associated. We'll talk a little bit more about what else might be going on there. First, let's talk about two names that we use. It's going to be really important for you to get to know these names: explanatory and response variables. Whenever we're dealing with two variables, it's often useful to think of them as one of them being the explanatory variable and one as being the response. The explanatory variable is the variable we think is potentially explaining the change in the other variable. Sometimes this is also known as the independent variable. So it's the one we kind of think of as the starting variable, and then the other one as responding to that. And the response variable then is the variable that's being impacted or changed by the explanatory variable, sometimes known as the dependent variable. Now, I just said that not all associative relationships are causal, and these tend to suggest some causal relationship here, that the explanatory is causing changes in the response. That's often what we're interested in trying to see. But we don't always find that there's a causal response. So we often use these labels even if we don't know that there is a cause and effect relationship yet. Um, they're just kind of a frame for us to think about how the variables might be related. If we think about two variables, smoking and lung cancer, that we just talked about, which one would be which? I encourage you to pause the video and try to decide for yourself. Here, it would make sense to think of smoking as potentially explaining why someone has lung cancer rather than vice versa. We wouldn't tend to think of lung cancer as explaining why someone is a smoker. So, oftentimes, we can kind of pair up these and figure out how we would connect one as the explanatory and the other as the response. And the other one makes less sense in our minds. One note, it's often a time related thing. Typically, you wouldn't have lung cancer and then that would cause you to start smoking because that would be the reverse in time. If you smoke first, then that might end up causing lung cancer later. Does smoking really cause lung cancer? Let's talk about this idea, confounding variables, and a little bit about the history of the relationship with these two variables. A confounding variable is a variable that is related both to the explanatory and response variable. I think I have a little typo there. In such a way that it affects its effects on the response variable cannot be separated from the effects on the explanatory variable. So it's confounding in that it's con means together and founding the foundation. We have these two variables that together might be the foundation for the changes we're seeing in our response, and we can't really separate them and figure out which is which. So, for a long time, there was a question about does smoking cause lung cancer? And some people argued that there might be a confounding variable, this other variable that's stepping in there and is actually connected to the changes we're seeing in lung cancer, people getting lung cancer. And it's also connected to smoking, but we don't know which one is actually causing the lung cancer. Is it the smoking or is it this other variable? And the potential confounding variable that some people put out there were a number of ideas put out there, but one was some kind of genetic factor. So some people just have a gene that disposes them to really like smoking and also disposes them toward getting lung cancer. Why would this be a confounding variable? Well, it's a variable that's related to both smoking. It potentially makes people more interested or more susceptible to wanting to smoke. It's also related to the response variable. It seems to be the thing that's potentially causing people to be more susceptible to getting lung cancer. So that was the idea, this variable that's connected to both of those in such a way that, well, we can't tell, is it the smoking or is it the genetic thing that's causing people to get lung cancer? Uh, Ultimately, we don't believe that this confounding variable exists. Why not? There are a few keys to establishing a cause and effect relationship and believe that it actually is smoking that does cause lung cancer, and we have come to that conclusion. One is one of the keys. You have to establish an association between the variables. If we never saw any connection between smoking and lung cancer, there wouldn't be any reason to think smoking causes lung cancer. But over and over and over again, we consistently see people that smoke also have a higher rate of lung cancer. So there's this association that's well established. We also then need to eliminate all possible confounding variables. Um, so we had to rule out that there was some kind of gene that was actually causing people to get lung cancer and also causing them to be interested in smoking. So there are different ways to eliminate a confounding variable like that, a gene. You could do genetic kinds of studies and things like that. But here's one of the trickiest things that we need to be thinking about. We have to be thinking about all possible confounding variables. That means not just a gene, but any other possible thing that might come up that might be connected to smoking and lung cancer. And part of what's real tricky about that is that all of us might think really hard and come up with a list of possible confounding variables, and then someone else might come up with an idea none of us ever thought of before. So, what does that mean? Does that mean we can never establish cause and effect because there's always some other possible confounding variable out there? It actually doesn't. And statisticians have found a way that they believe eliminates all other possible confounding variables. That's what we're going to get into in our next video. So I encourage you to check that one out. Quick recap of this one, we can talk about two variables being associated, connected in some way, but not necessarily in a cause and effect relationship. There's a difference between those two things.